Hi class, welcome to an introduction to quantitative research. Up until this point, we've considered primarily qualitative research. Now we turn our focus to quantitative research, which really is all based around numbers. Unfortunately, to understand quantitative research, we have to delve into statistics and some different types of statistical methods that are utilized. But they're key to understanding how this research is conducted and how we can take away what's found and see if it's real or if it's true or if it will impact our practice and if it's information that we can use in improving our professional practice and the programs we design for our clients, our athletes, and others that we work with. So the objectives for this presentation are to basically kind of introduce you to this shift that we're making from this qualitative type of information to quantitative information, go over some key terms, and start introducing some of the statistical concepts that we'll be talking about over the next several units. So first off, what I really want to focus on at the start is an understanding of what a variable is, because quantitative research is all about variables, measuring things, determining what to measure, to really tease out the important information from the studies that we're conducting. Variables also allow us to sort of place our subjects into different categories. So variables include not just measures like speed, agility, quickness, body weight, height, etc. Variables also include characteristics about the subjects or the people that we want to study, such as sport participation, position they play, gender, etc. So we're going to go over first what a variable is. Then I want to talk about in studies how we select subjects, and that's called sampling. So we'll talk about sampling and the different ways to sample and other important terms and concepts related to sampling. We'll understand a better, or hope to have a better grasp of the term sample as well as population, because generally what we're attempting to do is make some kind of inference or learn something about a population or how a population may react to a specific type of training program. We can't study the whole population because that might be millions of people, so we study a sample. So we'll go over concepts like that. I also want to mention measures and how measures are selected by researchers. If your goal is to increase somebody's speed, should you choose a 40-yard dash, a 100-yard dash, a 10-yard dash? Should you choose, an agility drill or something like that? But how do you choose measures, and how do you make sure that researchers are choosing the best measures or the ones that are most applicable and are going to give us the best data? That takes me to the last objective, which is to go over the concepts of validity and reliability. These are concepts related to the measures that researchers will use and allow us to tell, did they choose the right measure? Did they choose a measure that we can have confidence in? And we'll go over those terms in depth as well in this presentation. So anyway, I'll try not to get too heavy into stats in this course, but we will be talking about some of these types of concepts as we move forward from this point. And it will make you a better reader of the research and allow you to better understand what these researchers are finding. One of the key terms and concepts related to quantitative research is the concept of a variable. You've all read a lot of research, I'm sure, and have a pretty good grasp of what a variable means. But a variable is something that can be measured. It can be an attribute of your subjects. It can be a condition that you apply to them, such as a specific treatment condition. It can be an ability that you measure, such as 40-yard dash, jump height, flexibility or range of motion. Again, it's something that can be measured, or it's a measure of some type of attribute. There are different types of variables, and I want to spend some time making sure you understand what they are, because sometimes variables are numbers, sometimes variables are categories. So sometimes in a study, maybe we want to compare males and females, or we want to compare endurance athletes to non-endurance athletes. That's a variable. The gender or sex in that first example, or the sport they participate in, or the type of activity they engage in. Those are variables, but they aren't ones that you can measure with a number, but they are categorical variables. So those are variables where, again, we can place people or place their results potentially in a specific category. Those can be nominal variables where, again, it's just a name, but the name itself or the category doesn't imply anything about the other categories. So eye color is a nominal variable. There's blue eyes, brown eyes, hazel eyes, and not one is better than the other. Versus another type of categorical variable would be ones that are ordinal, meaning that there is an order to them. So if we were categorizing football players from NFL players to European League football players to college football players to high school players, not only are those nominal, different names, but they also have a ranking where we know the NFL players are likely the best players. The next label down is not as good, and so on and so on. So categorical variables, though, they don't have a number applied to them, but they, again, allow us to group people or group performance or group something, and so on. So these variables can be observed, but you don't measure them with a device or a tool. Continuous variables are ones that are observed but also can be measured. So a person's height is a continuous variable, meaning that it can go up, it can go down, we can measure different levels, and it's continuous, meaning we have a whole wide range of potential scores. Versus in categorical type variables, there's only probably a set number of eye colors, for instance, or sports that a person can participate in. Versus continuous variables, there's a whole range of measures that are available. So often, in a lot of the research we see often potentially we want to look at something like a different type of treatments, maybe different types of warm-ups, a static stretching warm-up, a dynamic warm-up on some measure of performance like sprint speed. In that case, we would be breaking people into these categorical variables, by the treatment that we apply to them, and then measuring some continuous variable such as sprint speed. So again, those are just examples of the different types of variables that are out there. And it's important that you consider those when you're reading the research that we'll be reading in this class, but also in other courses and just in real life when you're reading these different articles. Another term that I want to go over is the term of descriptive statistics. And we have another presentation specifically on descriptive statistics. But descriptive statistics is a branch of statistics that we can utilize to analyze and interpret data. Specifically, descriptive statistics tell us about a population. So they summarize information about a population, make it easier to interpret and understand what this population is like. So descriptive statistics often, are used to report a group of subjects, maybe their age, their height, their weight, and so on. And they allow us to get a better understanding of, hey, how tall are these people on average? What do they weigh? How many males are in the group? How many females are in the group? Those types of things. Descriptive statistics include a number of different measures, but the ones that we see most often are means, median, and mode, which basically tell us kind of where the average person is in a particular group. Measures of distribution, how far do they spread out? So yeah, the average height is 5'6", but we have a range of people from 4'10" up till 6'7" potentially. So it gives us a measure of the distribution of a group, and then it can also allow us to draw some correlations between groups. So in this table here, what we can see, this is just from a study that looked at how far soccer athletes run during a competition based upon their position. So position in this case, central defenders, external defenders, central midfielders, those would be categorical variables. So we've broken these groups, these soccer players, into these different categories of player. And then we measured how far they ran in the first half, in the second half, and total in a game. And these are in meters. So this tells us how far they've run over a particular competition on average based upon their position. The distance they ran is a continuous variable, right? It's a variable that has a whole wide of ranges, and so on. So again, this is just an example of some different things. What they've done there is taken the average or the mean distance covered for all the external defenders, for all the central defenders. And means are a descriptive statistic. So it tells us, on average, if I play central defense, then I'm likely to run about this distance in a given game. We also can see in this table the standard deviation. That's what this bottom number is. So it tells us that most of the people ran on average 5,082 meters, plus or minus 271 meters. So some people ran close to 5,300. Some people ran, 4,800 meters. So there is a range of distances in these groups. So again, this is just an example of descriptive statistics and how it can tell us about a population or subsets within a population. Now, descriptive statistics are fairly easy to understand. Interferential statistics are a little trickier, but it's important that we understand how these can be utilized. Interferential statistics allow us to make, inference or understanding of measures that have been taken. Descriptive statistics just tell us, hey, this is what we saw in the population we studied. Interferential statistics allow us to evaluate the numbers and determine if differences that we see between subgroups or what have you are real or true, or are they just due to random fluctuation in the measures. So, in the previous slide, we looked at the distances covered by these different positions in soccer. We see that there are differences in those measures. Well, are those differences real? If I'm an external midfield player, am I really likely to run 900 meters further than a central defender? Is that difference real, or is it just because of random variability? Maybe I got a bunch of people that really like to run in the external midfielder group. But again, we don't know. Are those differences between those groups real? Interferential statistics allow us to test to see if those differences are true differences. Are they likely to be just due to random variability, or are they unlikely due to random variability? So when you've read studies before, you've probably seen measures of this. Interferential stats typically report something like a p-value. And what those are doing is they're measuring what is the likelihood that this difference between these two groups is real or just due to random variability in the measures that we're taking. So interferential statistics allow us to determine if true relationships exist between the data and whether those differences are likely to be seen in others or in the whole population. So if the differences are true, then obviously we can be confident or have some confidence that we would see similar effects in the population we work with, in our subjects. So these interferential statistics, what do they really mean? Let's take a look at this example here. This is the article we read in week 1, where they compared, where they took subjects, remember, and had them do a delayed onset muscle soreness, eccentric workout to cause this delayed onset muscle soreness. Before they did the delayed onset muscle soreness, type of training, these were their baseline measures in oxygen levels within the muscle, looking at the counter movement, jump height, range of motion at the hip joint, and range of motion at the knee joint. So these are their baseline levels before we cause this muscle soreness. This is the measures before they did the foam rolling treatment. These are the measures after the foam roller treatment. And what we see are differences, right? If we look at the counter movement jump, they jumped 31 centimeters before the treatment. They jumped 33 centimeters afterwards. In the vibrating foam roller group, they did 33 and 36. So we see a change. We see an increase in jump height from pre to post treatment in these things. We see changes in a lot of them. Well, whenever you're measuring things, you're probably going to see differences. It's very unlikely if I ask you to jump right now as high as you can, and then 15 minutes from now ask you to do it again. While you'll be similar in your jump height, it won't be identically the same. It'll be different. Is that difference, though, significant? Is something different about you now than 15 minutes from now? No. It's just that there are going to be variability in your performance from time to time. The question, though, is that difference true? So if I am looking at pre-treatment and post-treatment, and I want to see if my treatment works, if it's more effective, then I need to use interferential statistics. And without going into the math of it, what it does is it says, hey, how confident can we be that these differences are real and not just due to random variability? And the way it does this is by calculating these differences, we get a p-value. P-values are important to understand because what they mean, when you see a p-value of less than or equal to 0.05, that is 5%, right? 0.05 means 5%. So that's saying that if I'm going to say that this number is different than this number, then I want to be 95% confident. That's 100% minus 5%. I want to be 95% confident that if I say these differences are real, that they are real. So that's what a p-value means. It tells me how confident do I want to be that this difference between the measures is true and not just due to random variability. So when you read these studies, if you see that there's a B next to this number, that means that we can be confident, 95% confident or greater, that the difference between the post-treatment measurement and the pre-treatment measurement is real and not just due to random variability. So this ability to use these interferential statistics lets us determine if these differences are real and can be expected in our own clients, our own patients, or not. So if I see a significant improvement, a statistically significant improvement between these two treatments, it tells me that, hey, maybe I should be using a vibrating foam roller over a non-vibrating foam roller. As you can see in here, we have a lot of A's and B's, and that means A is comparing the difference to the baseline, B is comparing the difference to the pre-treatment group. So we see that for the most part in this study, the treatment, whether it be the vibrating foam roller or the non-vibrating foam roller, causes an improvement in the performance measure. What I really want to know is the improvement even greater in one foam roller treatment over the other. So as we mentioned before when we looked at this article, really any foam rolling is going to cause a positive impact on all of the measures aside from maybe oxygen levels in the muscle. But the question I want to know is one of these treatments better than the other? And we can measure that by looking at these interferential statistics. We will spend time talking about interferential statistics over the next 4 or 5 units, so don't feel that you have to completely understand it now. We'll be looking at more and more examples of that as we move forward in this course, but I did want to introduce it here. So quantitative designs typically are going to utilize numbers and statistics to analyze data and analyze some aspect of performance. Studies may use descriptive statistics or interferential statistics. We see both in the studies that we'll be reading in our field. But quantitative designs use either descriptive statistics or, again, we use interferential statistics, and often we'll see both. Studies using descriptive statistics only typically are going to include things like test reports, surveys, and normative type studies where they're publishing the norms of a specific population in some type of test. A study that I'll share with you later that's called Anthropometric and Athletic Performance, Combined Test Results Among Positions Within Grade Levels of High School-Aged American Football Players, is a great example of a study that gives us descriptive statistics about a group. What it does is it gives us the norms for high school football players by position and tells us, again, average scores and so on. Really useful for us if I'm working with or training a high school football player because it tells me, hey, where is the average high school football player in terms of their 40-yard dash, their vertical jump, and it allows me to compare my client to those norms and see where he or she fits. Experiments typically take it a step further. While they will still often produce descriptive statistics and include descriptive statistics, they typically look to go further and investigate relationships between variables, specifically looking at cause and effect, trying to say that, hey, this treatment will cause an improvement in performance or a decrease in performance, and so on. So typically experiments, which are examples of quantitative designs as well, are going to look at these relationships between variables and how one variable potentially affects another variable. So an example of that would be the study that we just discussed on the previous slide, where we looked at the effects of vibration and non-vibration foam rolling on recovery after exercise with induced muscle damage. So again, we see a wide range of quantitative studies that can include descriptive statistics, interferential statistics, or both.